All right, we're going to do our practice test 2. Let's see here. Number 1, you have f of x is equal to negative 2x plus 6 squared minus 1. And we're trying to find the vertex. The vertex, well, we know that for a parabola in standard form, it looks like this. Minus, and then minus h squared plus k. Okay, so in this problem, the vertex will be at negative 6 and negative 1. Number 2. What is the vertex for the, is the vertex the parabola a maximum or a minimum? And this parabola opens downward, and since it opens downward, the vertex has to be at the top or a maximum. And we know it opens downward because of the negative sign in the front. If this was a positive, then it would open upward, then the vertex would be a minimum. Number 3. Give the vertex of the parabola. Okay, here's my parabola. 4x squared plus 8x minus 13. We're going to have to complete the square here. So we're going to first factor out a 4. X squared plus 2x plus something minus 13. And that something should be, well, let's see here. What I wanted to do is I wanted to make it look like this, right? Okay, so that's something I would think would be a plus 1, because half of that would be a plus 1, and the 1 squared would be a 1. Then if I add something here, I have to take it away. I have to take away what I put in here. What did I really put in here? I put in a 4, so I have to take away a 4. So that means this is going to be minus 17. So now my vertex is going to be at negative 1, comma, negative 17. Remember that the vertex formula is a minus, so minus a negative 1 gives me what looks like a positive here, and the 17 is negative because sign stays the same. Alright, well, I'm just going to use it the way it is here. Alright. Okay, number 4. Let's see here. Number 4. Give the right and the left hand behavior of the function. F of x is equal to 8x to the 6th minus 5x to the 4th and plus 6x squared. So we know that because of this even here, they must either both go up or they must both go down, okay? And something's going to happen in between, all right? I don't know what that is, but that's, or don't care what that is. And because this is a positive, they must both go up. If this was an odd number, like ax to the third, then they would have to both go in opposite directions, and something's going to happen in the middle. I don't care what that is at the moment, but since this is positive, it's going to have a positive slope like this. If it had a negative in front, it would have a negative slope. All right, number 5. Give the factors of the function. So let's see, we have x to the 7th plus x to the 6th minus 12x to the 5th. So let's see, this is f of x. Well, greatest common factor is x to the 5th, and this becomes x squared plus x minus 12. Well, I know that there are 5 zeros. Those are my factors. Or, I'm sorry, let me back up here. Those are my zeros. They didn't ask for the zeros, they asked for the factors. So the factors are x times x times x times x times x times, and this can be factored to x plus 4 and x minus 3. So those are my factors. If they asked for the zeros, then I would have had 0, 0, 0, 0, 0, and negative 4 and positive 3. Okay. All right. And number 6. Give the zeros. So now I have f of x is equal to 3x squared minus 5x minus 10. So we're going to give the zeros, so we're going to try to factor it. If we can't factor it, we're going to have to use the quadratic formula. So that will give me a negative of a negative 5 plus or minus b squared minus 4 times a times c all over 2 times a, and that will be a 5 plus or minus the square root of 25. This is 12 plus 120 all over 6. And then that simplifies to 5 plus or minus the square root of 145 all over 6. So if this could be simplified, it can't. So there's my factors, my 2 factors, right? My 2 factors for the function. Number 7. I think I need a new page here. I'm going to do some long division, or let's just do synthetic division. I will have enough room here. Number 7. Let's see. We're going to divide x minus 2, which is a positive 2, into negative 3, 4, negative 2, 4, and 1. 1, 2, 3, 4, 5, and I'm missing one. Aha! They try to trick me here. Let me see here. Let me erase this. I need a 0. Okay, I need a 0 here, and then a negative 2, 4, and 1. Okay, so let me double check to make sure I have those numbers in the right place. Negative 3, negative 6, negative 2, negative 4, negative 4, negative 8, negative 10, negative 10, and then it's negative 20, negative 16, and negative 32. That's a negative 31. So my quotient will be negative 3x to the 4th minus 2x cubed minus 4x squared minus 10x minus 16 minus 31 over x minus 2. There's my quotient with the remainder. Number 8. We'll find f of 3 using the our remainder theorem. We can actually just plug in the 3 or use synthetic division, right? So if we're going to use synthetic division, I'm just going to use the 3 the way it is, and then I'm going to have negative 1, negative 2, negative 12, negative 10, positive 7, and negative 4. So 0, negative 1, negative 3, negative 5, negative 15, negative 27, negative 81, negative 91, negative 273, negative 266, and then this will be negative 798, and then that'll be negative 802. So that is what it would have been equal to if we plugged in the 2 into our formula. Number 9. Simplify and write in standard form. So we have a negative 2 plus I minus 6 minus 7i. Distribute that negative sign. Add my like terms. I should get negative 2 minus 6 is negative 8. I plus a 7i, which will be 8i. Number 10. Multiply 6 minus 4i times 5 plus 3i. I know my real part of my number will come from the top part. This will be 30. And this will be a negative 12i squared, which will be plus 12, because I squared is a negative 1. And then I have my imaginary parts, which will be negative 20i and positive 18i. And then combining all that together, I should get 32 minus 2i. Okay. All right. Number 11. 5 minus 2i over 4 plus 7i is equal to, or before we go equal to, we'll have to multiply this by the conjugate of the denominator on the numerator and the denominator. When I multiply this out, I get 16 plus 49. And foiling this out, I get a bunch of terms here. I get 20, and then I get a negative 14, and then I get negative 8i and negative 35i, which then becomes 6 minus 43i all over 65. And then write it nicely with the real part and the imaginary part. Okay, number 12. Find the third degree polynomial with the zeros 1 and 3 plus 2i. Okay, I'm going to start by writing my negative like this, and then writing this one here. And then, since imaginaries come in conjugate pairs, I'm going to have another one. So I'm going to put this in here, minus 1, the minus 3 plus 2i, and 3 minus 2i. Okay. Then I'm going to regroup this. I'm going to have x minus 3 minus 2i and x minus 3 plus 2i. And seeing that I have this difference of squares now, if I regroup that, this becomes x minus 3 squared minus 2 minus 2i squared. Okay, and then I can say that this is going to be x minus 6x squared minus 6x plus 9, and then this is 2 times 2 is 4, 4 times I squared is negative 4, minus a negative 4 is plus 4. So this is really x squared minus 6x plus 13. Now I distribute the x minus 1 to it, and then I can get x times all of that will give me, let's see here, x cubed minus 6x squared plus 13x. That doesn't look too pretty. 13x. And then for the other one, for the negative 1, I'm going to get negative x squared plus 6x minus 13. And combining my like terms vertically, I get x cubed minus 7x squared plus 19x minus 13. That is the third degree polynomial for those two answers. All right, next we have intermediate value theorem for that function. Okay. All right, for the IVT, you want to make a table. You're going to use your calculator. And you're going to put in, this is number 13. You're going to put in your function. So there'll be 2x cubed minus x squared minus 3x plus 5. Then you're going to look at the table under table mode. And you can see that starting at negative 3, negative 2, negative 1, 0, 1, 2, 3. The table mode I have negative 49, negative 9, 5, 5, and 3, and 11, and 41. So you can see it approaches from the negative side, and you're going to be looking right here. You're going to look here, but you're going to write here. Okay, so I look for a sign change. I see that there's a sign change right here. So that means I'm going to write between negative 1 and negative 2 well, actually, I'm going to write that backwards here. -2, -1 is where I'm going to have a 0. I'm going to have a 0 between -1 and -2 because the graph goes from a positive to a negative on this side. All right, so the graph is going to look something like this. It's going to go through here, and it's going to keep on going like that. So between -2 and -1, I'm guaranteed to have a 0 because the graph went from a -9 to a +5. So between the -2 and the -1, I'm guaranteeing a 0. So you look here for sign change, look in the Y for sign change, look up and down for sign change, and where it changes, where it passes the x-axis, it's going to go from a negative to a positive or a positive to a negative. Then you write down that between -2 and -1, there has to be a 0. Right? Okay. Number 14. Number 14. We have rational zeros test. Determine all of the rational zeros. P over Q. In this case, P is 10 and Q is 2. All the factors for 10 are 1 and -1, 2 and -2. What else goes into 10? How about going in order? 3 doesn't go into 10. 4 doesn't go into 10. 5 goes into 10. Does 6 go into 10? No. Oh, by the way, 2 times 5 make 10. That means I've already come around to the opposite direction on my numbers. So then that means 10, because this makes one set and this makes one set, and there can't be any more because there weren't any more on this side. What makes 2? What are factors for 2? Plus or minus 1 and plus or minus 2. So now you're going to write this out here as the possible rational zeros are 1, -1 over 1, or 1 over 1, so plus or minus 1, and then 2, plus or minus 2, plus or minus 5, and plus or minus 10. Now you're going to do the same thing for all the denominators of 2. So you're going to have plus or minus 1/2, and then plus or minus 1, which I already have, and then 5 over 2, plus or minus 5 over 2, and then 10 over 2 is just 5. I already have those, so these are all of the possible zeros, rational zeros, using the P over Q test. Okay, number 15. Descartes' rule. You have x to the 6th minus 4x to the 5th plus 4x to the 4th, or x to the 4th, and then x to the 3rd, and then 2x squared, and then 5x, and then plus 2. Now looking at all the positive zeros, you have a plus, minus, plus, 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 minus, plus. So how many times is it going to change signs here? I have a 1, 2, 3, 4. So there's 4 positive sign changes. If we look at this and we look at the if we put a negative in here, 6 negative signs would still be positive. And then this will be a negative, so 6 negative signs would be positive. 4 negative signs would be positive. 3 negative signs would be negative. 2 negative signs would be positive. 2 negative signs here would be negative. And then there is no change in this one because that's a constant, that's positive. So how many sign changes do I have here? Positive, positive, positive. 1, 2, 3, 4. Okay, so let me see if I did this correctly. Got positive, negative, positive, positive, negative, positive. And this one's positive, 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 negative, positive, negative, positive. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, so there could be up to 4 positives and 4 negatives on this problem using Descartes' rule. All right, number 16. Number 16, find the zeros. So you're going to see that this is a to the 4th power. Okay, so you're going to put this in your calculator. And x to the 4th minus 6x cubed plus 9x plus 6x minus 10. So that looks good, and we graph that, and I see 2 zeros. Let me trace it just to make sure. I think I see one at -1. Yep, -1 is 1. And I see another one at 1. Yep, I confirm those two are zeros. And then it looks like the other two are imaginary because I don't see them on my graph. So we're going to do some synthetic division here. We're going to take a -1, 1, 0, -6, 9, 6, and -10. So that's going to be 1, -1, -7, 7, 2, -2. Wait a minute here. Let's see what's wrong with this. 1, -1, -7, +7. Ooh, that's a 16. That's a -16. That'll give me a -10, and +10, that's 0. All right. Now I'm going to do a +1, and that's going to give me a 1, -6, -6, +10, 10, 0. Now the other two are imaginary, so I probably won't be able to factor these. So I'm just going to go ahead and hit my quadratic formula. Minus a -6 plus or minus the square root of -6 squared minus 4 times 1 times 10. Okay, so then I get over 2 times 1, and that's going to give me 6 plus or minus the square root of -4, which is 2i over 2. Dividing both of those by 2, I get 3 plus or minus 1i. So there are my other two zeros. And I have found all the zeros. Number 17. Number 17. We have find the horizontal asymptotes. The horizontal asymptotes, that is when you have to look at the x terms, the highest order ones, okay? And then you can kind of ignore the other ones. Let me see what tool I have here. Let's spray the blue. Okay, I can ignore that stuff here, and I'm only just looking at that. So I'm just looking at that. I can see that it is bigger on top. If it's bigger on top, then there are none, no horizontal asymptotes. If it's bigger on the bottom, if the exponent was bigger on the bottom, like 2x squared and x cubed, then y is equal to 0. And if they're the same, then you cancel them out, and it will be the ratio of the numbers, the coefficients in front, which will be like 2 over 2, or whatever, a over b, right? All right, number 18, almost done. Find the vertical asymptotes. The vertical asymptotes are what's going to make you divide by 0. Okay, so you have to look at the denominator and make sure there are no zeros down here. So when I factor that, I can get x plus 2, x plus 1. So I know my vertical asymptotes are going to be x is equal to -2 and -1. Number 19, last one, determine the domain. The domain, there are only 2 rules so far. You don't care about the numerator. Do you have an x in the denominator? Yes. Do you have a square root? No. So make sure your square roots are positive and the denominators cannot equal 0. You can solve this by factoring it as a difference of squares, or you can add the 16 to the other side. Okay, either way comes out the same. You get a plus or minus 4. That cannot be 0. So your domain's all real numbers, all reals, except for x cannot equal 4 and -4. Or you can say from -infinity to -4, jump over the -4, go to +4, jump over the +4, and continue going on to infinity. All right, that's it. Okay. Good luck tomorrow. You're going to have 2 where you're going to actually have to graph it, just like on your quiz that you just took. All right. You may want to practice some of those on your own. All right. I didn't want to make this video too long. All right.